Thank you for attending today's Tech Talk. We're going to be talking about building enterprise software with open source projects. We intend for this to be applicable to a wide range of audience members, whether you're an engineer, product manager, or a CTO. Here we are. All right, so who are we? I'm Chris Sanders, Director of Customer Reliability Engineering at Replicated. I've most recently also worked at Canonical, makers of Ubuntu, and AWS, Amazon Web Services. Between Canonical and Replicated, I've now spent the last 10 or so years shipping open source software specifically targeted at enterprise use cases. I'm particularly interested in sustainability and open source and enterprise use cases, which help fund the cycle of open source for all of us. Marc?
Hey everyone, I'm Marc Campbell, the CTO and co-founder of Replicated. Spending a lot of time in my career building infrastructure software and delivering infrastructure. It's a fun space, and happy to spend some time here talking about open source and infrastructure.
Awesome. So let me go ahead and kick it off with one of those free-form questions for Marc. So as founder and CTO, you set the tone for Replicated and how and if we engage with open source. Can you tell us a little bit about your previous startup experience and what brought you to heavily embrace open source when you founded Replicated? Like what problems did you anticipate or advantages did you see?
Sure, yeah. So when we started Replicated, and we'll get into a little bit more in the coming slides about what Replicated does, but when we started Replicated, we really looked at, we wanted to help commercial ISVs ship their software into on-prem environments. And that we were looking at application portability was a big thing. And this was pre-Kubernetes days. And we realized infrastructure is a fast moving space in that time as it is till today. We were kind of going out a little bit with early containers, early Docker, and really just leaning into open source as the solution for a few different reasons. And again, I think we're going to talk more about that. That's the primary reason that we're here. But the challenges, I think, are really, it's a fast moving, everything is constantly changing. There's a lot of different opinions. There's a lot of different ways to solve stuff in the infrastructure space and a lot of different competing open source projects. And so being able to find one, making sure that we're able to contribute to it in a meaningful way, sustainability of that project, things like that are all big parts of it.
Awesome. Well, you kind of foreshadowed it, but I think next up is some background on Replicated. So I'll let you take that one away too.
Sure. As I mentioned, Replicated is a startup that we're here to help commercial ISVs ship the on-prem, the enterprise installable versions that run behind the firewall in their larger enterprise installations. We work with a lot of different large ISVs. We've been around for about 10 years. And if you think about what it takes to actually ship your software, it's more than just packaging it as a Helm chart. You have to think about how you're going to test it in various Kubernetes distributions. You have to think about how you're going to release it and license it, and how to handle reporting of those installations, how you're going to support it in those installations. And so that's what we focus on. It's really not about shipping to one of those end customers. It's when you want to really scale that distribution so that you can make it really, really easy and really predictable to run for your customers to install complex software behind the firewall in complex environments.
Fantastic. So this slide does cover a lot. And so I've got a way I like to express in a hopefully concise manner the problem space we're talking about. So when you consume your own software, there's a lot of great open source tools that help you build, deploy, and manage software. In fact, that's what the hyperscalers do, and they contribute very heavily to open source. So a lot of those tools become very good. However, when you have to send that software to someone else, your options become significantly more limited. There's no guarantee you can use your favorite GitOps, observability, or even packaging tools, and Replicated helps with that lifecycle, specifically focused on customer managed environments. All right, Marc, let me get you another question. So Replicated's been in business for 10 years, and that approach has evolved. We've approached this problem space slightly differently. Can you tell me a little bit how the problem space has changed over the last 10 years and how you see it kind of changing in the future?
Sure. I think the problem space is continuing to change. Initially it was, large security conscious and customers want to run your software behind the firewall. It's a financial service, government institution, healthcare, for different reasons. They don't want to push all the data to multi-tenant SaaS. They wanted to bring the application in, run their own instance of it. That problem hasn't gone away. And in fact, with modern tools, a lot of these AI companies, it's even growing. A lot of folks do want to bring the models into their environment and run those instead of shipping all of the learnings and the fine tunings to the model out to all the different AI companies. Mm-hmm. So the problem space is continuing to really grow with AI especially. But I think like the solution, which I think we're here to talk a lot more about, is like the actual solution that we're actually building. That's changed a ton over the 10 years that we started. When we started building this product, it was pre-Kubernetes. Kubernetes did not exist at the time. It was still, Borg, Omega, like internal to Google. Docker was out. I think it was Docker 0.6 at the time. And so we built, like everybody did back then, we built a container scheduling and orchestration system to help solve this problem, and we shipped that. And over time, Kubernetes became the clear orchestrator and leader in the space. And so we kind of shifted to adopt that. And then even more recently, with Helm 3, I think, we see Helm 3 as like the kind of the default and good packaging manager that everybody's choosing. So it's even becoming more and more specific. So I think the way that the solution has evolved over time has been that there has been maturity in the ecosystem, maturity in the tooling around, we had containers and now we have Kubernetes and now we have Helm, and we have like standards that are becoming more and more widely adopted by enterprise, which makes it easier for you to ship your application because it's not like custom packaging, custom everything on top of it.
Yeah, so Kubernetes really changed everything. Do you see any other emerging technologies or trends that you think are either exciting or concerning in this space? Like, do you see anything else that might be changing in the near future?
Yeah, I mean, the way that we look at it is, the continued evolution of these, right? So Kubernetes is continuing to evolve and solve some gaps that aren't perfect and aren't, and nobody's saying that Kubernetes is perfect. Like for portability, especially around things like ingress and networking and storage. These are areas that are really hard, and those are continuing to evolve and get better. Helm, at KubeCon just 2 weeks ago in Salt Lake City, we were talking to the team there about like some of the changes that are coming to Helm 4. I think that there's a lot of obviously, like stuff in reporting and observability. eBPF continues to like create new technologies that we want to adopt. Overall, I think like we're not looking at like a platform shift coming up. I think it's really just maturity of the tooling that we actually have out there right now, though.
Fantastic. Do you think VMs are going to remain a thing? Will containers eventually take over, or are we stuck with VMs for a long time?
I think we're stuck with VMs for a long time. I think, like there is absolutely, like I mentioned before, like a movement for, a category, a class of applications to just run on-prem. So it's not just the Fortune 100 that want to run stuff on-prem anymore. And on-prem, I say on-prem, but let me be really clear. The vast majority of the time, on-prem is somebody else's cloud environment. Like my AWS environment is my on-prem. It's not actually servers that I'm racking and stacking and installing, stuff on in the closet. So I think that, the move to multi-tenant SaaS is great, but like you do see more and more single tenant managed and kind of various, like it's not like it used to be binary where it's like, I'm going to send all my data into this multi-tenant SaaS, or nope, I want like an airgap disconnected environment and run everything on it. I think like there's a lot more variance now in how actually software can actually operate. And I think that creates a really good efficiency.
Fantastic. Well, that's a good lead into our installer products, which we do expect VMs to still be a thing, thankfully. So our installer products are the area of the platform that our work with Mirantis has really happened. Today we have two install methods, the Helm SDK and an embedded cluster. The Helm SDK is for people that just want to use Helm in their install pipeline. Helm truly is the common base that most enterprises build their Kubernetes software around. So to ensure you can deliver anywhere, we have the SDK. It's a small microservice that gives you access to licensing, telemetry, and update checks from the replicated platform. Then secondly, we have the embedded cluster. This is the product where we're using k0s by Mirantis. With the embedded cluster, you distribute your application and the cluster as a single installer. You get a ClickOps experience so that end users don't have to know how to operate Kubernetes to consume your application. This is where we target the VM installation methodologies. We have previous generations of this product, but this k0s based version has recently gone GA for our vendors, and we'll be using examples from that process, both selecting and building the embedded cluster for talking about the discussion today with open source. So Marc, both Helm and embedded cluster have open source in them, but there's a different approach. Helm SDK uses open source, but not in the same way as embedded cluster. Can you tell us a little bit about the differences between these two approaches?
Yeah, I mean, so I think that they're both really, really valid. And I think the way that we look at when you want to replicate it looks at when you want to distribute your software to an end customer, you have a variety of customers and they come with a variety of opinions and a variety of tooling and maturity levels for how they actually want to operate that software. One of the biggest challenges with running on-prem software or distributing the software to your enterprise customers is just the variation in their environments. You might test everything really, really well on EKS, and then your customer comes and brings like a 2-year-old version of OpenShift, and like your application doesn't work as well on that because of security constraints and different things or different container runtimes. So we choose to really we think that the path is really look at this embedded cluster solution, and we're going to talk more about it, really built on top of k0s to remove that variation and say, bring some VMs. Kubernetes is an implementation detail of how the software is going to work, but you don't have to be a Kubernetes expert in order to actually run the software. If you're an ISV and you're packaging your application, yeah, you need to be a Kubernetes expert. You need to actually understand how to, write all of the different manifests, the Helm charts, and everything that are necessary to run the application in that environment. But end customers, when they actually want to run it, they should just be able to spin up some VMs and then run some software. That should be the default, and we're really striving to make that the default even at scale because of some of the work that the k0s team and Mirantis has delivered on the project that makes that really possible for us. There are always some exceptions, though, and it might be very specific workflows, or you have a customer who says, "Oh, but this is Kubernetes, and I have existing clusters that I want to run this on," or maybe the application needs to run co-located in a cluster that has a bunch of other applications on it. And they have a requirement they run Istio sidecars with everything. The advantage of Kubernetes is that common API, and so because of that, you do end up with some customers who, for very valid reasons to make the application compatible with their workflows and make it supportable for them, they actually have very opinionated pipelines to get stuff deployed. And in that case, it's just add a subchart in, deliver a Helm chart, and these are customers who, luckily, just by definition of them, they bring that Kubernetes expertise, and so they can actually figure out how to configure and run a Helm chart relatively easily.
Right, and our strategy on that has changed over time too. So this wasn't isn't something we just intuited. We've seen this in practice, so we've kind of learned over time what Marc's talking about there. So we've tried a couple of different things, and this seems to be the one that really fits the market well. Cool. Let's move on to some of the evaluation process. And so we haven't really talked much about the predecessor to our embedded cluster. It's called curl with a K. But the key reasons for us to build a new product was to make some improvements from our time using it. So similar to what Marc was saying, you learn over time, you see what's happening. And curl is also based on open source. It's based on kubeadm. While I wasn't around for the decision specifically around kubeadm, it is open source. It's made by the upstream Kubernetes community, and it does describe itself as a tool built to provide init and join as best practice fast paths for creating Kubernetes clusters. So it does sound like a really good project for exactly what we're doing. Let me get off the title slide there. I can see why that would be an appealing choice. If you aren't familiar with kubeadm, it uses standard Linux packaging to deliver the necessary host packages to install Kubernetes. While this is a fine way to deliver packages on Linux, it means different packages for different operating systems. It also means dependency resolution between the packages that are required by Kubernetes or other software on the machine have to be dealt with. There's a good example of a solution that works. This is a good example of a solution that works really well when you own it internally, but it can also become cumbersome when you start delivering it to a third party because you don't get to make all of those choices. You don't control the machines. The next pain point, which isn't completely unrelated to host packages, is a smooth upgrade process. Especially in an air-gapped environment, host packages make upgrades not as smooth as you'd like. I recall a time when I had a cluster fail on Ubuntu because a version of Containerd wasn't new enough for the new version of Kubernetes. These types of problems are harder to discover since some packages come from Kubernetes community and others from the operating system distribution. It greatly can increase your testing matrix to make sure you understand all the variations in that case. Finally, we wanted to be able to reset when an install failed and have some confidence we could retry the install without prior configuration getting in the way. It wasn't uncommon for someone to do an install with an incorrect proxy or no proxy settings at all because they just didn't realize they needed them. But with config files scattered across the machine, it sometimes was difficult to make that change and rerun the installer without keeping kind of that historical config around. And we saw users getting confused with that. So I want to emphasize when evaluating products like this, it's beneficial to start with your true minimum set of must-have requirements. It's very possible with a long list that you will find no software lives up to your needs. Before you start evaluating, be sure to make sure this list of requirements is reasonably small. So I only listed a few things here, and that is exactly where we started. Marc, beyond the technical challenges of curl, were there strategic considerations that influenced our decision to build a new generation of installer tooling?
Yep.
For sure. It's obviously it's very related, right? Like, I think that I can't really separate the technical challenges versus like the decision to say this product's not solving it, because if we weren't running into some technical limitations, we would have been able to, like, in theory, solve everything that we're looking to. But at its core, like, what we are trying to do is look at installation success. When you're packaging your application up and throw it over a firewall and let some end customer run it in a complex, like I said, even sometimes a hostile environment, it's hard to actually get that install to work really, really well and predictably. And we were looking at the way we were packaging it before, and customers would come with like forked versions of CentOS, or they came with like old packages, Chris, like you mentioned some of those. Mm-hmm. And a lot of like things like that became hurdles for us that we had to overcome. Or large organizations sometimes would provision a VM, find out it wasn't the right VM, but without a good way to uninstall and start over again, they had to like say, I need to, like, the install failed, I want to try again. But it would take them, like, this sounds weird to somebody who kind of grows up in like the world of AWS, create an EC2 instance in a second, but it might take a week or 10 days in order to get a VM replaced. And so that actually just increased that cycle. So I think the core product challenge for us is we look at, we want to see how high we can actually make installation success rate. We want to measure it, and we want to say, look, you can get, what percentage of these installs work out of the box every single time. And we realized, like, there's a natural limit because of some of the technical limitations of how we were packaging it before, that we're not going to get to a number that we're actually high enough confidence in. And we're evaluating everything, and we actually look at the core thing on k0s was the static compilation, because it removed all these dependencies, and it removed host packages, and it gave us, very likely support for like forked versions of old CentOS and things like this. You just, there's some category of problems that you can't get any real guarantees it's going to work around. But I think from a technical level, it seemed like that was the best solution that we could also think about. And then the other things, like you mentioned on here, like the ability to reset and try again without having to provision a VM. And we just realized, like, this gets us to the place where we can probably get these installs to be a lot more successful. And it's not going to be trivial for us to do. It's not going to be trivial for us to throw, away one version of the product. And sure, we actually have a clear upgrade from that version to the new version, so like people can do in-place upgrades. But we think that it is the path to getting us to that success that we need.
Great. Well, let's talk a little bit about those evaluations then. So after we narrowed down the options, the technical review covered several distributions that varied in their approach, goals, and features provided. One important note here is I still reviewed the possibility of kubeadmin. You see it at the top of the list. It's always helpful to evaluate if perhaps it wasn't the project specifically we struggled with, and possibly just an implementation decision that we made. That isn't what we selected this time, but it's worth the self-review. Now, I do have experience in the Kubernetes space. As I mentioned before, I worked at Canonical, and as it turns out, I was actually managing the Kubernetes products team, including micro-k8s at the time. It's important to try and put personal bias aside. Just because I was familiar with micro-k8s, I need to be careful not to be tempted to jump into using it. In fact, I was not very familiar with k0s when we were gathering the information. I still have some notes where I was gathering information to guide some discussions on which distributions we were needing. And I found this note in one of my early summaries that I thought was interesting. I noted, with the above considerations, it's probably worth some time for technical leaders to review the k0s project. Many of the issues we face in curl today are being addressed directly by that project. I thought it was really interesting when I did that, because I didn't really know k0s, but because I took the time, and it was, I think, the last one I reviewed, it turned out the last one I reviewed really fit the project well. So don't pigeonhole yourself into something you may already know, or even just because it's popular. Make sure you take the time to just stop and look at what other options are out there. Marc, when we looked across these distributions, some of them offered features we wanted, maybe just not as a default configuration. A good example of that would be a CNI. Sometimes you'd see a CNI that was flannel. Sometimes you'd see Calico. We liked Calico, and some of the distributions, including k0s, had that by default. Do you draw any distinction between readily available default options versus extensive customization on a project?
I think that we can't, honestly. It's a good question. I think, yeah, like, we're looking for that project that literally chooses all the same defaults that we would choose. And it's like, why wouldn't we choose this project? But like, that's kind of a little bit of a unicorn and maybe like unattainable. I think it's really, though, if there's an open source Kubernetes distribution that says, and now here's where you can plug in whatever CNI, whatever network interface you want, versus here's 3 of them. Our default is, let's say, flannel, and we chose Calico for different reasons. As long as it is supported, that's okay. It is nice though when you do come across the project that you're so aligned with like the goals and the way it is, and it's we're trying to be opinionated about our product. When an open source project shares those same opinions so closely that like most of their defaults align, it does start to feel like like it's going to be more work to choose a different project at this point. And Chris, you and I talked early in the days too about it when we're like, looking at some of the technical decisions that an open source project makes, and we realize like literally that's the same decision that we would have made, or like so close to the same decision that we would have made that it just makes it a really easy choice. And then there's some other ones that we had, it might be like storage, that we had an opinion, like here's what we want to do, but like we're willing to like kind of come back and look at our opinion and say, does it matter? Is it differentiating enough? And do we actually want to force like our own storage opinion on top of this? Or does this thing actually solve our goals in just a way that we hadn't thought about yet, and open up that conversation?
So as we've been discussing, we did choose k0s. It did meet a lot of our requirements, as well as passing the community and alignment and the other stuff we were talking about before. I like to give an example of being in alignment with the project because we happen to have a really good one with k0s. So the k0s project considers upgrades of the cluster part of the distribution. Its batteries included and clusters have to be upgraded, so they address it. When we started, we used k0s Cuddle, their Go command line tool, to allow us to orchestrate upgrades. However, the Mirantis team later launched Autopilot. It's a sort of in-cluster operator to perform the upgrade and distribute images to the nodes. We switched to that implementation, which fit what we were looking for much better. It was a really good indication that we were working with the k0s team and not against them. In fact, they actually have another product called, I think it's Cosmotron. Hopefully somebody from Mirantis will correct me if I'm wrong on that, which is a cluster API compliant management for k0s clusters. This is also something we might be interested in the future, and continues to kind of reiterate that the team is thinking ahead of us in the same direction that we're going. Marc, k0s wasn't really widely known at the time, or at least it wasn't to me. It wasn't as widely known as some of the others. And they even had a little snafu with their GitHub where their stars got deleted and reset, which can give some people some heartburn. How much emphasis do you put on things like GitHub stars or whatever adoption metrics you can have when you're evaluating a project?
Yeah, I mean, I actually remember that because I remember when we were first looking at it, I was like, this project only has like 200 stars. Are we sure? And so clearly there's some value. And like, yeah, we did understand that was GitHub stars got reset on the project. I think, you should be careful, obviously, with GitHub stars because, like there are ways to get those star numbers up without actually having a vibrant project. So I think we just look at it overall with the vibrancy of the project. We got to know the maintainers of the project pretty well. We got to really understand what they're actually building. We got to make some contributions and actually try out like how willing and how receptive are they to us kind of helping share what we actually want, and that, like we feel like it's aligned. How receptive was the team? And then we honestly, because it is a newer project, we even went a little bit deeper. It was a newer project when we were starting it. We went a little bit deeper, and we actually got on with the lead engineers and the project managers for the team, and just really shared exactly what our intents were. And does this make sense? Are we, is this a use case that you see us continuing to be able to maintain and support on top of it, and make sure that we had really good and open communication about what our plans were with the team. And we're happy with the vibrancy and like the work of the project. We've contributed, to GitHub issues that the k0s team is considering, at the time making it a CNCF sandbox project, which solves some other challenges that we have, but we're able to vocalize, in there and share why we support that move.
And you're kind of leading right into the next conversation, which is we did vet it. So we didn't stop at GitHub. We don't stop at, okay, it looks like the project does everything. Exactly what Marc's saying. We reached out to the Mirantis team. We talked to product and engineering leadership over there. We wanted to hear what they thought and if it's still aligned. And they were very clear. They wanted to provide a cluster. They wanted to provide a great cluster experience. They really liked the product we were talking about building on top of it. They felt like it fit well, and there were no conflicts with where the projects were trying to go. So that gave us a lot of kind of confidence. We did some prototypes as well. Engineers from our team reviewed the code. We submitted some bug fixes when things looked out of place. In our example, this all went very smoothly, but don't forget, you're still vetting the project at this stage. prototypes should be to learn, not to jumpstart your new feature development. It's important that you be able to change your mind after you spent some time with the project and prototyping. It might be that you got in and you found that it was hard to work with, or it didn't really fit the needs you need. And you don't really know until you start writing some code and do a little bit of prototyping. I know we talk about this and it kind of sounds like maybe this just took a few weeks, but it didn't. During this process, we've been through a lot of different vetting processes. I personally run a home lab. I like to use that when the decision's large enough. This one was. And so I migrated my own hardware over to k0s so that I could see it firsthand. That cluster's now been running for just about 300 days. So to give you an idea of how long I've been working with the project. It also helps me to understand how it works. So as we've been building embedded cluster, I had a much better understanding of exactly how it works myself. And I understood what it looked like operationally. Marc, what do you like to do? Like, how do you cut through the marketing? Like, I'm a big home lab person. Like, what do you do when you say, how does this really work? How do you like to dive in?
Yeah, I mean, all those things, right? Like, for sure, taking the code and actually running it and getting comfortable with it. We follow a very an inspired product methodology where we're willing to take these bets, but like they're all reversible. So making sure, you talk about this, prototype that we actually did, like that wasn't structure. We were really careful to structure that in a way that like, if the learning was that it's going to be really hard to work with this project, it's okay. Like we're just going to spend a couple of weeks and really evaluate it because it's worth that investment. And the other thing is really like join some of the community meetings. Like I know that the k0s team, we got to know them and like had them on podcasts and really listen to kind of their vision and their let's say their energy really about how they're talking about it and the way that they're framing the project and like giving us more confidence on a technical level. Like our team really got familiar with the code. Our team really got familiar with the implementation. The bet that we're making is really just on like the longer term sustainability and compatibility with what we want. And so that just becomes, a little bit of it takes time. You watch the project go through a few release cycles and you see how are they delivering on the commitments and on the roadmap items, and like how are they responding to community issues. How are they responding to our issues? How are they responding to our issues when they disagree with them? Because like that has to happen too. Like we're not trying to like take over an open source project and say, no, this is the thing that we want. And so really understanding what those paths are. And honestly, like even to the point where we understand, what if there is a release that's incompatible with what we want to be able to do? Like, how do we think about, worst case scenario would be like maintaining a fork for a period of time. Like we haven't had to do that yet, but like, like understanding what all those look like before we're actually be able to say that we're all in on it.
I really like that specific example. A good example of how close our team is to the code base is we have carried patches from upstream to release something that wasn't yet available in k0s. So we found something that was really important to us. It was accepted to be upstream. We went ahead and made that available to our vendors because we knew it was going through the release process. We worked with the team to land it, but we didn't have to wait. And when it did land, we just simply dropped the patches. So we are very close to the code base, and it's very helpful to be close to the developers as well. So let's take a few minutes to talk specifically about that implementation, Marc. So I did mention before the prototyping, and we've learned from a couple different prototypes. One of the decisions that can be difficult to make, especially when integrating with an open source project, is whether you're going to, assuming you're in the same language, whether you're going to vendor in the open source project or you're going to use it as a binary and a dependency in some fashion. Is there a way you approach this? I know we went back and forth on our own implementation. How do you weigh those factors, Marc?
Yeah, I mean, we did, right? Like, and we're fortunate to have that decision here because we write our code in Go, k0s is written in Go. So we're not like, sometimes the decision is just made for you if the project's written in a totally different framework or language and it makes it impossible. But a lot of this comes down to, how like tightly coupled we actually wanted it, how modifiable by the end customer. If we just bring a binary in, there's some options here for like additional functionality that we didn't test with because they could run the binary, they could run CLI flags, they could replace that binary with a different version. Like that would probably like break compatibility with stuff. But like if we bring it all in as a library, then it becomes ours. And then you also have to think about how the end customer is going to perceive that too. If we wrap everything as a library, this is our distribution now. We can talk all we want to about how it's built on top of k0s, but it is our distribution, and there may be security concerns or challenges that you have to go through for vetting and onboarding into these enterprise environments. Bringing the binary in, we can just say we're just driving this binary, and it is this. it is definitely a trade-off though. There's not a clear, this way is always better than that way. Like, I think you really have to look at what your goals are and how your end customers are going to be willing to adopt it, especially when you're distributing it and they're running it in their environments.
I really like that distribution angle. I don't think we really mentioned that before, but like replicated doesn't need to be a distribution. And I think it helps us out sometimes when talking to vendors or end users that we're using a distribution that is well known. In fact, they could go get that same distribution. We don't have to stand on our own on that.
Right.
So we've definitely made changes along the way. We've talked about these kind of two-way decisions when we prototype. That can get a little more tricky depending on how tightly you couple. So like you made a mention that we do couple very tightly to k0s. The autopilot we were talking about is one fairly tight coupling. How do you decide when to couple tightly like that? Because it makes it a lot harder for us to say, rethink the decision of k0s itself. Like we can choose features back and forth, but switching to another distribution because we're so tightly coupled would actually be quite a bit harder. How do you balance that?
Yeah, I think it's just really comes back down to the same, like when the value there just outweighs that risk and outweighs that cost. I think that we look at autopilot as this easy way for us to manage upgrades, and we know the cost, like the challenges of managing upgrades, like historically, and so we're more willing to take that risk. Also, early for us on the adoption, there's kind of two other parts to it. I think for us, we were pretty early on the adoption of the project and actually shipping our own product based on it. So it gave us a little bit more flexibility. It was an alpha release at the time when we were evaluating this, or pre-GA, which gave us kind of I don't know if it's a true sense or a false sense that we could actually say, let's undo that change and not worry about it. Like the problem though kind of is the last bit, which is knowing that there's like a path off of it at some point if it doesn't work out. Like we don't want to leave customers with installs that can't be upgraded. And when we adopt a piece of functionality like this, we just want to really dig in and understand kind of how it works, know what it's doing. We don't have to get really in the weeds and understand every line of code necessarily. We don't have to we're not trying to replace it, but we do want to know what would it take to replace it if it no longer was critical path to the k0s project, or it no longer we needed extensions and functionality on top of it that it didn't actually support. How would we actually be able to upgrade into a different solution if we did have to build our own?
Fantastic. Let's talk about some of the learnings and what we might do differently if we had thought about it again. So I know you've been heavily involved in helping the team focus recently in our embedded cluster product on reliability, reducing complexity, and things like that. Can you speak to your approach when you go to integrate another project? How do you think about complexity and the proper way to integrate just from a higher architectural level?
Yeah. I mean, we don't want to fork. We don't want to maintain patches when we don't have to. We want to basically use the open source project in the core way that it's actually designed to be used, that aligns with that team's vision and goals. And so we can hopefully we're not writing thousands and thousands of lines of code to integrate it in. Else, that code to maintain that integration sometimes can be as complex and sometimes even more complex than actually just building it yourself. Which is we talk a little bit about the Helm deployer stuff. I think that's an area that we started to really evaluate whether we're crossed that line or how close we are to it. Compare that to the autopilot work where we actually think it's a really low effort to maintain an integration into autopilot, and it's doing a ton of value for us. And so we're not going to look at replacing that, but really just, making the decision. I actually look at it as the default should be to try to use that open source project. Unless you instantly know it's going to be way too hard to integrate and maintain that piece of functionality. But just make sure that you understand what that looks like moving forward, because complexity kind of creeps up on us over time. And, then the next thing you know, you're like, why is this project so hard for us to ship? And you realize it's because this thing that we thought we were doing, our product requirements have changed to be 100x that, and it's no longer the right solution. We should have reevaluated it at some point.
Fantastic. So I know another common difficulty when pulling another project is testing. In our case, we're talking about a Kubernetes distribution. How do you balance testing your product with the level of effort when you have such an important piece such as a Kubernetes distribution that you're leveraging?
Yeah, I think that's an area we didn't really talk about, and maybe we should have earlier when we were talking about how you evaluate open source projects. You need to understand how they're testing it and what the kind of the contract that they're having with you. If you use that, what should you be expecting? Obviously, you don't want to pull in an open source project that's buggy and shipping regressions all the time. That's a challenge. Like, because of this exact point, you want to just say, look, you open source project k0s in this instance, what you're able to do is deliver us a conforming Kubernetes cluster and deliver us upgrades when we actually submit an autopilot job. I don't want to like test that. Like, I have confidence in the team, in the project's current implementation for testing that, because of two things. One, we've kind of evaluated it. We looked to see how they're actually doing it. We understand the framework. We actually, interestingly, took some practices from it too into our own project, because there was some good stuff there. But also, like, we've gone through enough of those iterations. Like, projects are going to have bugs. Open source projects are the same as any kind of other project. Bugs are going to happen. So it's not like looking for bug free, but just understanding, how do they test it? Like, are we seeing kind of the same types of issues over and over again? Like, how confident do we get in their ability? When we test our project, we test basically up to that integration line really, really well. We're not testing does like every feature of k0s work. That'd be insane. Like, we're actually really relying on the upstream project to do that. But we actually do still run end-to-end tests, which encompass some of that overall functionality, just for confidence that the upstream project is, it's still the same upstream project. It still has the same APIs, the same functionality that it had before.
Right. So we might run an upgrade test, but it's not because we're necessarily validating k0s. We're not going to matrix it across a bunch of different options. We're running the upgrade test to test our part of the workflow, and because we still want to see it work end to end, but we're not going deep into. And if we had a problem, and I think we've done this before, we'd work with the upstream community. So we don't need to always put a test case in our project if the bug or the regression were in the upsource project. Right? We'll go to the upstream and work with them on the testing as well. It's super important that you try to bring those things to the right project. So if you have an upstream problem and you can get upstream testing it, then they're going to be ahead of you. And so they're going to catch problems way before they release, as opposed to you catching it later. So it's beneficial for everybody. If you've got a bug that you think is actually in the other project, you test it in the right spot.
Yeah, you obviously can't test the entire upstream project, or else you're kind of taking away a lot of the value of using open source projects at that point, because you're still putting a ton of work into it. And also, like, that'll change as time goes on. But this really comes down to a key part of your evaluation criteria when you're looking at a project is how confident are you in their testing, and like how, like, it's absolutely worth digging into, not just like, does the product do the thing I want, but like, how mature is the testing framework that they're actually shipping to.
Fantastic. I think we're maybe a minute or so over, so I think we'll probably call it there. Thanks for all your time today.